Sir, can you hear me?
Yes, please go ahead.
Thank you, sir. So, can anyone tell me what this picture means, or what do you think when you see this picture?
দেখে মনে হচ্ছে নদীতে সাদা বরফ পড়ছে এরকম।
Yes, at first glance, this might seem like ice, but this is actually industrial waste. This picture is from last year. Our neighboring country, India, has a big industrial waste problem, and this is the picture of Yamuna River with toxic industrial waste frothing all over. Today, our topic is heavy metal pollution in surface water of Bangladesh. We are Group 5, and on behalf of Group 5, Roll 132, 147, and 141 will be presenting.
Well, we know about water pollution, but what about specifically heavy metal pollution? The most familiar heavy metal that we know about is arsenic. So let's look at this scenario. Before 1993, the water supply coverage in Bangladesh was 97%. And in 1993, when the presence of arsenic was discovered in groundwater, it went down from 97% to 74%. Besides arsenic, there are some other heavy metals too that are found in the surface water. For example, zinc, cadmium, lead, etc. So why are we talking about heavy metals? Why does it even matter? It matters firstly because it runs through the food chain from the surface water to the consumer's body. And there it gets accumulated and it poses severe health threat to them. For example, it causes bone vulnerability, brain damage, damage of the central nervous system, etc. And secondly, it causes the devastation of surface water ecosystem. And then, we know that heavy metals are toxic, they are harmful, so what are the responsible organizations doing about it? So here, our country have this Environmental Conservation Act 1995, based on which the ECR 1997 standards are set for the different water quality parameters. ECR provides water quality standards for drinking water and for wastewater effluent from industrial units. Apart from these, we have also used some international guidelines in our study. They are the WHO guideline, the US EPA guideline for sediments, and the International Marine Water Guidelines.
So, what is the current situation of heavy metal pollution in Bangladesh right now? For our study, we have found out that the most affected three water bodies for Bangladesh is river water, coastal water, and city water. From 2000 to 2020, 60 major rivers were tested for heavy metals in Bangladesh, and almost all of them had at least one heavy metal above the standard drinking value. Obviously, Buriganga is the most contaminated in every aspect. There was no surprise here that it was the first one in heavy metal too. Almost all the heavy metals were found in exceedance of the standard drinking value. One thing that we found out from our review that chromium is the most abundant in our rivers. I think this is because of the source or the type of industrial development we have. So let's see, why do we have so much heavy metal in our water? So this video shows us that there can be three sources of heavy metal, and the majority comes from in the untreated industrial effluent. For Bangladesh, Bangladesh, tannery and textile industries use a lot of chromium, and this is where the chromium abundance comes from. Another minor source is domestic waste, and another part comes from agricultural pesticides. Coastal water. This is considered as a different zone because of the difference in sources. Along with the industrial developments, there are many gas-based power plants and shipbreaking yards in our coastal areas. And because of this different source, lead and cadmium are found in abundance in the coastal waters. So what about our lakes? Well, if anyone has come to Mohammadpur, they know that, what are the lakes? Dhanmondi Lake and Hathir Jheel. Oh my god. So this thing also reflects in the heavy metal data. This is statistics published in 2014 showing the average heavy metal concentration in Dhaka city lakes, and we can see that our average values, lead, zinc, chromium, copper, all of them exceeds the standard by at least 100 times. So we are engineers, right? We should not talk about only problems. There must be some solutions too. Yes, there are. Conventionally, these four methods are used, but they are very expensive, and for large-scale implementation, they are not much feasible. Modern studies, modern scientists have proposed two methods, residual sorption and phytoremediation, as a solution, feasible solution for heavy metal absorption. Residual sorption will use the industrial sludge as an absorbent, where phytoremediation uses a plant to absorb the heavy metal directly from water. This is an example from Philippines, where they have used plant-based phytoremediation technique to clean up their wastewater canal, and there have been some scientists have hopes that this technique can be used in Bangladesh too.
Let's look at the summary of our project. Increasing industrialization and consequent discharge of untreated industrial waste is the major cause of this heavy metal pollution. Most of the major rivers and the water bodies near industrial development areas are contaminated. These pollutants are non-biodegradable and toxic in nature and have expensive treatment procedures. Thus, identification of heavy metal point sources and preventive measures against this discharge can be the way to reduce the quantity of this untreated industrial waste. Thank you for your time. Feel free to ask any kind of question.
I have one question.
Okay, please go ahead.
First of all, congratulations Group 5 for giving such a visually attractive yet so informative presentation. In your slide, in the remedy section, modern techniques, you have said about phytoremediation. As our topic was tannery wastewater, do you think we can apply it in our Buriganga River in order to soak the heavy metal by using this technique, or are we using phytoremediation right now anywhere in our country?
I am so happy that you asked this question. Really so happy. I have so much to say about this topic. Even last year in 2019, there have been experiments here in our geotechnical department in Buet, how we can use phytoremediation to fight heavy metal pollution in Buriganga. There are already some experiments going on where potted plants are being used to soak up heavy metal from soil, but it has not been tried for water yet, not for Buriganga water yet, but this has been tried for water in different countries. Especially in 3 countries, I have found studies, Thailand, Nigeria and Philippines, where they have tested heavy metal absorption from water using vetivers, and they have shown variation of 35 to 70% efficiency. I have found studies where researchers have expressed hope that vetivers can be used to clean up Buriganga, But personally, because I have done some research in with vetiver, I can tell you that vetiver alone cannot help Buriganga. Phytoremediation is not that powerful, but combined with other techniques, other mechanical techniques and preventive measures, this can yield a very, very good solution. Thank you.
Okay, thank you. Any more questions? Okay, so thank you for the nice presentations, and yeah, definitely it was very informative one. And as I wanted to say it later, but I guess I can say it now because it's already the foundation is already laid out by Akash. So basically, so far I am happy to see the presentations of all of your group. Specifically, I should say that the slides are very good, mostly very good. Yeah, there's still some room for improvement for all groups here and there, but in general they're very good, and thank you for taking it seriously. That's good to see that you're taking this task of the term project seriously. It's for everyone. Okay, so now come to the specific questions. I have specific questions for three of you others who haven't talked today: 131, 171, and 74. So my one question is, you have shown in the presentation the heavy metal in lake water. Can you go back to that slide, please? The city water. So this is from different lakes in Dhaka, right?
Yes, sir.
Okay. So can these three of you, either of you, 131, 171, and 74, can you briefly explain me what could be the source of this heavy metal? Because like in Dhanmondi Lake, I don't think there is any like connection of tannery or those things. So why there are so many heavy metals here? And also there is no pesticide in urban agriculture.
Sir, one thing
I wanted to hear from the other three persons who haven't presented, who haven't talked yet.
Sure, sir.
Sir, এটা মেইনলি স্যার আমরা যে পেপারগুলো থেকে স্যার এই ডাটাগুলো নিয়েছি স্যার, সো ওখানে স্যার মেইনলি ইন্ডাস্ট্রিয়াল ওয়েস্টগুলো স্যার মানে অ্যাকচুয়ালি অ্যাকুমুলেট হয়ে এখানে মানে অন্যান্য জায়গা থেকে স্যার ইন্ডাস্ট্রিয়াল ওয়েস্ট যেগুলো এসেছিল স্যার ওগুলো আস্তে আস্তে স্যার অ্যাকুমুলেট হতে মানে এই পজিশনে আসছিল, মানে ওখানে যে সোর্সটা স্যার বলার ছিল আর কি।
এটা তো লেকে কি কোনো ওরা কি কোনো সোর্স সম্পর্কে কিছু বলছে?
স্যার মানে সোর্সে স্যার মেইনলি ইন্ডাস্ট্রিয়াল ওয়েস্টের কথাই বলেছিল স্যার।
ধানমন্ডি লেকে কি ইন্ডাস্ট্রিয়াল ওয়েস্ট আসছে
স্যার? আর একটা স্যার ওই যে ইলেকট্রনিক ওয়েস্ট সম্বন্ধে স্যার মানে ছিল স্যার, মানে সোর্স হিসেবে লেখা ছিল স্যার যে ওখান থেকে বিভিন্ন স্যার ধানমন্ডির যেটা বলতেছিলেন স্যার মানে ওই লেকগুলোর আশপাশ থেকে স্যার ইলেকট্রনিক ওয়েস্টের একটা পসিবিলিটি আছে চলে আসা, মানে ই ওয়েস্ট আর কি স্যার যেটা।
Okay. Okay. Tarsina, do you want to add anything? If you want, you can.
Sir, we have presented an old statistics. I wish there were some recent research on Dhaka City Lake, like the situation in 2020 right now.
Okay. Okay. So now 131 and 74. Any of you can answer this question. So in your presentations, you have mentioned about ECR and you showed the value for 1997. Are there any updated version of ECR 1997? Was there any modification or any latest version? Are you aware of that? Okay. Any of you can answer it if you want.
স্যার মানে
1997 this year, এটা কোনো আপডেট হয়েছে পরে? 2005 এর একটা ভার্সন আছে না তোমাদের C332 বইয়ের ল্যাব ম্যানুয়ালের যে লাস্টের দিকে যেটা, ওটাই তো বোধহয় 2005।
পেপারে আমরা এরকম কিছু দেখিনি তারপরের আপডেট।
এটা পেপারটা হয়তো আগে দিয়ে দিতে পারে, এটা একটা আপডেট আসছে। মোস্ট অফ দ্য ভ্যালুস আর সেম আছে, বাট হওয়ার জন্য যেটা হচ্ছে রেলেভেন্ট থাকার জন্য লেটেস্ট এটাই থাকা উচিত আর কি, সেই জন্যই আমাদের ইনফরমেশন হিসেবেই পাওয়া। ওকে, সো thank you for your presentation, sir. Next group, please.
Thank you, sir.
তোমাদের স্ক্রিন শেয়ার করতে পারো।
স্যার আমার কথা কি শোনা যাচ্ছে?
হ্যাঁ, তোমাদের এরপর ক্লাস আছে 11টায়?
জি স্যার, মাফি স্যার ক্লাস আছে 403।
ওকে
স্যার আমার ভিডিও অন করলে নেটওয়ার্কে প্রবলেম হয়, মানে কথা কেটে কেটে যাবে, সেজন্য আমি স্যার ভিডিও Good morning everyone. Today we group 6 will talk about one of the most crucial water pollution problems in Bangladesh, and that is arsenic contamination in groundwater. We all know about arsenic contamination more or less, that is it is toxic and carcinogenic for human beings. WHO declared arsenic contamination of Bangladesh as the largest mass poisoning of a population in history. At first, let's see some data on to which extent arsenic has spread in Bangladesh. Arsenic is found in mainly shallow tube wells due to overexploitation of groundwater. About 80 million people are at risk of exposure. A study performed in 2012 estimated that arsenic exposure causes 19,000 adult deaths annually in Bangladesh. And it's sad but true that the provisional WHO guideline for drinking water is 10 micrograms per liter, whereas the national standard is 5 times that. Hello, am I audible, sir? Sorry for network issue. Sorry, sir. Next, we will see when arsenic was first detected in Bangladesh. Arsenic was first detected in 1993 in Chomogram village of Nawabganj district, and 4 tube wells were found to contain arsenic. In the following year, 8 arsenicosis patients were identified in the same village. Many studies have been taken in 2000 decade for testing arsenic contamination in Bangladesh. The 2 important studies are presented here. The initial screening that concluded in 1999 had tested 51,000 tube wells, which revealed that arsenic contamination was present in 211 out of 460 upajilas. Subsequently, in 2003, a nationwide blanket survey covering 57,482 villagers revealed that out of 4.95 million tube wells for arsenic contamination, 1.44 million tube wells were contaminated. And at present, 62 out of 54 districts in Bangladesh are marked as arsenic contaminated. Let's move on to the next topic, which is the origination and the methods of arsenic entering the groundwater in Bangladesh. Bangladesh is largely located on the Bengal Basin formed by the Ganga, Brahmaputra, Meghna river system. This sedimentary basin has been formed by deposition of large volumes of arsenic-containing sediments that originated mainly from the Himalayas and was carried down by the mighty GBM rivers during the Pleistocene and Holocene periods. From these sediments, arsenic is leaching into the groundwater aquifers located in the fan deposit areas at Holocene alluvium. Next, we can see arsenic cycle, which involves a large number of diverse chemical and biological reactions, namely oxidation, reduction, precipitation, methylation, and etc. These reactions control the availability of arsenic. Though the exact mechanism of the arsenic leaching into groundwater is not clear, three mechanisms have been